Hey everyone, welcome back to the channel. So this is the question for day 3 of 2024, January day 3. Now, what this question is the prime example of is a medium question having an easy solution, but the question is framed in such a complex way that it's very difficult to understand the question. What exactly are they trying to ask here? So this is the reason why I would say it's maybe marked as medium. Now, let's see how we can solve this. First, let's understand the question. We have a zero index binary string array. Zero index basically means that starts with the index 0, and mn is the dimensions. Bank of I represents ith row. Okay, 0 and 1. Basically, we have list of string, as you can see here. Okay, and in the list of strings, we have 0, 1, 1, 0, 0, 1, right? So what the 0 represents is an empty cell. 0, 1, 1, 0, 0, 1. 0, 1, 1, 0, 0, 1. Okay. So the 0 basically shows an empty cell, and 1, 1 is 1 means it has a laser emitter or a receiver. So this black part is a receiver, red part is a emitter. Now, what is the next thing? There is one laser beam between any two security devices. This is a security device. I'll call it security device now. If both conditions are met, what is the conditions? The two devices are located on two different rows, R1 and R2. You can see here, if the devices are on the same row, then we don't have any laser beams in between them. But if the devices are on two different rows, then it's the receiver part, the black part, which is the receiver part of the device, will receive a laser beam from the emitter part of the device, the red part, which is the emitter part of the device. And for each row I, there are no security devices in the ith row, which means that between any two devices which have a laser beam between them, there should be no other laser beam devices. If there was a device here, then the first row would have created a laser beam between the first row and the second row. The second row would have created a laser beam between the second and third row. Okay. So if there is any device between two devices, then as you can see, they'll create laser beams between each other. And it's like this. You can have a device on the next row, but if you have one, then that becomes the receiver for the for the devices on the previous row. So let's go to the whiteboard to understand this better. Now this here is a representation. So here you can see 0, 1, 1, 0, 0, 1. Okay. Now let's assume we don't really have this row with us. Let me just move this real quick. I'll make this else. Remove this. Oh. There we go. Now, if I were to calculate how many laser beams we have, that would be this row has 3 and this row has 2. 3 into 2, we have 6. Now, if I were to calculate between this row and this row has 2, this row has 1, 2 into 1, 2. Total 8. And that is the answer. So, how will we basically get these values then? The best way to calculate this is to have one variable called previous row. I'll have one variable called row, which will iterate over all these rows, and then we have the total. Okay. Now, previous row will always have the last maximum number of devices that we found, or last actual number of devices that we found. For example, here previous row will be 3 initially, and row will also be 3 and for the first row. Basically, row and previous row are counting the number of ones in that string. So because 1 represents a device, right? So the number of ones means the number of devices that we have on that row. So previous row equals 3, row equals 3, total is 0. In the next loop, next iteration, row becomes 0 because row goes to the second row. This one, row is here, but previous row, I'll mark it as blue, is still here. Just a minute. There we go. So previous row is still here, whereas row has reached here. Okay. And let me quickly actually mark previous row and blue. There we go. So it's still 3 and row is 0. Now row goes to the next one. It becomes 2. Previous row is still 3. 3 into 2, 6. We added 2 total. Now, since we have reached a row value where the value is not 0, I'll reset the previous row value and assign it to assign the value of row to previous row. So now previous row is here, because we cannot have any laser beams between this row and this row, as there is one row with devices in between them. So we have to reset it to the next row. Now the previous row is here, row is here, 2 into 1, 2, 6 plus 2, 8. Total is 8. There we go. We get the answer. Now let's code. Coding this is fairly easy. First, we'll have total beams equals 0 and previous row equals 0. Now for every row in the list, which is the bank, for every row in the bank, we'll first count the number of rows that I have. So previous row is the 0, current row, every row in bank, current row equals row dot count. Just count the number of ones in this row. So I'm basically getting the number of ones in the current row. Okay, great. Now total beams equals, plus equals current row into the previous row. If value of current row is greater than 0, basically anything other than 0, I want the previous row to become the current row. The previous row to have the value of the current row. Okay? And then in return, total beams. Let's run this. There you go. And if I submit this, we get a really good, really efficient solution, in fact. And the space complexity is fairly good as well, as you can see. Nice. I'll see you guys in the next one. Bye-bye.